Hello, and welcome to a special edition of Ethanol Producer Magazine podcast. I am your host, Katie Schroeder, Contributions Editor with EPM. Today, we are hearing a panel preview for this year's upcoming Fuel Ethanol Workshop. This year, Track 5 is exploring AI, digitalization, and advanced process control. Nitin Ranjan, founder and CEO of GOLGIX, will be presenting in a panel titled Real-World Applications of AI in Ethanol Plants, happening at 10:30 a.m. on Tuesday, June 2nd. Nitin's presentation is titled How an Ethanol Producer's AI Journey is Reducing Variability, Detecting Contamination, and Protecting Fermentation Yield. So glad to have you on the podcast today, Nitin.
Thank you. Thank you for having me.
Yes, absolutely. So just to get started, could you introduce yourself and share what GOLGIX is all about?
Sure. For GOLGIX is a production intelligence company. We help producers make faster, better, quicker decisions so they can cut variability from their process and improve their yield. My background specifically is in industrial data analytics. I've spent 2 decades analyzing machine telemetry or machine data set, sometimes referred as brownfield data, and really into process control, worked with oil and refining. Early in my career, did a lot of energy optimization project and started building into AI since 2014. So have background in applying advanced technologies like AI to industrial data sets in very complex industrial use cases. And so that's how we came out building the company, GOLGIX, which is really focused on process industry, continuous process manufacturing and production.
Awesome. Thanks for sharing that. Kind of as ethanol demand is growing, you've noted in the past that the pool of experts who really know how to run these plants isn't growing with it. And I'm curious, what, from your perspective, does that pressure look like day to day for the ethanol producers you interact with?
Yeah, it's a real squeeze, and I think most plants are feeling it, whether they talk about it or not. As we know from the market data, that demand is expected to grow roughly around 20% by 2030, and that means more output, more efficiently. And most plants, where we go, we see 1 to 3 people who truly understand how to sustain peak performance. And when one of them leaves or close to retirement, that institutional knowledge walks out of the door. And all of this is happening while people are losing 2 to 4% of their yield to just normal variability in the plant. For context, that's roughly 2 million gallons a year per plant. So really the challenge is, how do you hold performance when you can't always rely on having the right expert in the right place? And that's really the question driving everything we are going to cover in the session. How do you deliver more output with fewer of those rare people and experts?
Yeah, absolutely. That's always a challenge. And yield losses can start way upstream, but don't show up until much later in the process, you've mentioned. And I'm curious, why are those so hard to catch in time?
Yeah, and that is, I would say, is the most frustrating parts of running an ethanol plant. By the time you see the problem, the damage is already done or it's past you, and we keep either chasing it or with some information chasing ghost, I say sometimes. So really, yield is shaped by many conditions interacting across the whole plant process, from grind all the way to dryer. And it's not just one thing. So even a small upstream shift in your cooked solids or slurry density can ripple through multiple downstream steps in a way that usually are not obvious. And usually, this delay is the biggest killer. The yield loss you see today might trace back to something that happened a shift or two ago. And most of the monitoring in these plants are siloed by unit ops. So every unit operation has its own monitoring, and the people are kind of disconnected between the multiple operations. So you're looking at each piece separately instead of looking at the full chain and the full train. And that's why the root cause is so hard, and you're looking at the wrong place at the wrong time. So what we have found is that solving this requires a full plant view, like all the way from grind to the dryer. And that's exactly the lens we will walk through in the session at FEW.
Exciting. I'm looking forward to hearing more, and I'm sure our listeners will be excited to hear some of those answers. From what I understand from the title, it sounds like this is going to deal with real life application of this technology. And I believe you mentioned this presentation is based on a real producer's AI journey. And I'm curious, what did they think the problem was coming into the plant? And then what did you learn, and what did the data actually show?
Yeah, and this is actually my most favorite part of the story as well, because it is relatable, and we wanted to provide information, context which is relevant, which everybody can relate to. So in the session, I would cover like most plants, they had a sense. Everybody kind of have a sense of where their variability is coming from, but it was like mostly based on what's visible and what they could measure. And when AI started connecting, or I should say, like when our software started connecting data across the full process, patterns, emerging patterns in different unit apps that you cannot really see in a siloed operation, some root causes were in places where nobody was looking. Some were operator driven, some were equipment driven, some were hidden in the timing between the stages. And the journey isn't about how AI replaced a team. It is about how an AI gave the team a view they never had before, and that changed their day-to-day decision making process. So I don't want to give it all away, but the gap between
Yeah,
what
yeah.
they assumed and what the data showed is something a
Mm-hmm.
lot of producers are going to recognize in their own plant. So yeah, looking forward to the session.
Exciting, exciting. Appreciate giving us a little sneak peek there. And the next question I have here kind of dives into like what is AI finding that some of the standard tools like CIP schedules, lab testing, or antibiotic programs are missing?
The honest answer is the standard tools tells you that contamination happened, right? Whereas the AI tells you why, and it tries to tell you before it happens, right? Like it's trying to give you that foresight. So what we started seeing were like contamination stress signatures that were at random. They were clustering in specific fermenters or specific weeks or specific time of the day. And those patterns usually point towards a specific root cause, but without an AI lens, it could be perceived as random events or random clusters. So the existing protocols weren't catching the pattern because they weren't designed to look across batches and over time. They're looking at one batch sheet at a time. When we found the
Mm,
sources and corrected it, we are seeing the variability drop by like 65, 70% in the process. And the specific root cause and how straightforward the fix turned out to be is something I want to walk through in the session, because it's the kind of thing that makes producer want to check their own data immediately.
absolutely. Coming out of this session, what is kind of the main message you plan to convey to your listeners in this panel?
Really, to be honest with you, the main thing I want them to leave with is a different way of seeing their own plant. Every case study which I will cover in this session is from a real plant. So the before and after results are also measured. So they will leave with a framework they can apply, not just not just a concept, a food for thought. And the through line across all of it, that is sustainable yield gains, come from managing the full process, not optimizing one unit operations at the time. So it's really about the holistic view. The advantage of having the holistic view is key here. And if they're losing yield to variability, how can they trace it back? From fighting contamination events, which they can predict, or watching energy costs swing through like a clear cause, like energy swing without a clear cause, right? So this session will connect those dots. And after the session, if you have more questions, find us on booth 419, and we are happy to look at what the data might show for their specific plant. So I will close with saying that the producers who get most out of this won't just watch, like they will come ready to compare what we found to what they are seeing. That's when it really gets interesting.
Absolutely. I'm curious, what are you looking forward to most this year at FEW?
Last year was our first time there. We didn't have a lot of expectations last year, but we met some amazing people at that time who are now our customers or our partners. So we made some very good relationships. We learned a lot about the industry. We learned a lot of, new disruptive things other companies presenting there are doing. So it's really, I think, one of the best events where a lot of people from different walks of life, different parts of the same, um, you know, I would say community come together and really talk about their current challenges, what they're seeing, what they're more excited about, what they have tried and kind of like, moved away from. So just having those learnings from the people, having some real conversation, talking about some real problems, and then, connecting with them is what we are looking for.
Awesome. Well, thank you so much for giving me just some insight into GOLGIX and what you guys are all about, and excited for all of our attendees to hear your presentation in full. For our listeners, if you want to catch Nitin's presentation, it will be on the Real World Applications of AI and Ethanol Plants panel at 10:30 a.m. on Tuesday, June 2nd. Go to few.bbiconferences.com to see the full agenda, register, and learn more. We hope to see you there.